Let's think about what happens when we add like terms. Sometimes we get so caught up in working with exponents that we think, oh yeah, when we combine these we're going to get x to the sixth. But remember, exponents keep track of the number of bases that are being multiplied. If we multiply these guys together, it's 4 times 5 is 20. There's 3 x's multiplied here and 3 more here, so altogether there would be 6 x's that are multiplied. But we're not multiplying these guys together, so we're not adding exponents. The final result is going to be x cubed. These are like terms. In fact, they're cubic terms, so it's 4 times x cubed plus 5x cubed would give us 9 of the x cubed. So we have 9 of those things, 4 of these plus 5 more of these. Likewise, if we have radicals, if we are adding these guys together, we're not multiplying radical 5 times radical 5, so we can't make it a 5. We just have 3 of these guys plus 4 more of these guys. Altogether, we have 7 of these guys. Just like adding 3x plus 4x, you get 7x. It's the same idea. We are not doing this. If we were multiplying these two things together as factors, then radical 5 times radical 5 would become a 5, and we'd multiply all that stuff together. But that's addition, so we got to be on our toes to recognize whether it's addition or multiplication. Well, here we can't even combine these two terms because they're not like terms. Or at least they don't look to be like terms. But that's one of the reasons why we need to simplify radicals. Let's try to bust some more of this 20 outside the radical. So we have a 2 times, we could write 20 as radical 4 times radical 5, and we know that radical 4 is 2, the square root of 4 is 2, so we get 2 times radical 5. So this guy is going to become 4 radical 5. This is the same number, it's just been simplified. We can't get anything else out of the radical sign. Meanwhile, if we go over here and we say, okay, let's try to mess with 45, if we're fortunate, we'll take, instead of doing 15 times 3, let's use radical 9 times radical 5, and we realize, oh, radical 9, positive square root of 9 is 3. So this is going to become 3 times radical 5. 3 times 3 is 9, so what we have is 9 radical 5. Well, looky there. Now that we simplified the radicals, we realize that these really are like terms in the end because they're both multiples of radical 5. So if we add these together, we are going to get 13 of the radical 5s. If we do this guy, just pay attention to order of operations and what everything means. An exponent tells us how many of these bases are being multiplied. So this means that 2 radical 6 is being squared. It's being multiplied by another 2 radical 6. So 2 times 2 is 4, and the radical 6 times the radical 6 is going to be a positive 6, because radical 6 is going to be this positive square root of 36, and that's going to give you 6. So 4 times 6 is 24. So that ugly looking thing right there is really equivalent to 24. This is a lot simpler. When we go over here, it's just a distributive property over subtraction. The radical 3 has to get multiplied by this term, and the radical 3 also has to get multiplied by this term. Well, when it gets multiplied by the 5 is a whole number. This is just a portion of 3. It's the square root of 3. So that will give us 5 radical 3. Then we have the subtraction sign. Now when we take root 3 times this, we're going to get 2 root 3. That term right there is going to get multiplied by this radical 3. So now we simplify that. Radical 3 times radical 3 is 3. So we're going to be left with 5 radical 3 here minus 2 times 3. So this is going to be 6. So in the end, we get 5 radical 3 minus 6. Now it may seem like we could do something beyond that, but we can't. Because they're not like terms, we can't combine them. So that's as simple as we can get it after we distribute. Then this guy. If we're dealing again with both numbers and variables, then what we need to do is factor all these things down. And look, you can do it any number of different ways, but how about we break it down to the smallest factors for each of these things. We can do it like this. There's simpler ways to do it, and if you understand it better, then just go right to a simpler way. But bottom line is, Anytime we have two of these factors that are the same, the radical of 2 times 2, the radical of 4, is going to become 2. So these guys are going to come outside the radical sign. The 3 is left underneath the radical sign. Now, 2 of these x's, that means we'll have radical x times radical x. That's going to give us x, because that's going to be the positive square root of x squared. So that's going to give us an x right there. And then this y times this y, when we can bring those two out, that's going to be a y. And this y times this y, they'll multiply together, and since we have the square root of y times y, that's going to be a y. The only things that are left under the radical sign are going to be the 3 and the x. Now I'm going to be real honest with you. At this point in time, I'm not going to make a big issue out of what if x was negative, because if it was negative, that whole thing wouldn't exist. We're going to talk later, we're going to get in the habit of, if we just take the square root of a variable squared, we're going to need to get in the habit of saying that the result is the absolute value of y, but we're getting there. For right now, let's just ignore all that. Ignorance is bliss, and let's just stick with this right here. What we're going to get, this is going to become 2 times x times y squared times the radical of 3x. Likewise over here, if we multiply all this stuff together, we can do this a little bit more quickly. Maybe not. Let's not rush it. So we've got times 3 times, let's factor the 10 so that it's 2 times 5, and then xy. Bottom line, every time we have a duplicate radical, like radical 5 times radical 5 is going to be just 5, so the 5 is going to come out of the radical sign. Here's an x times an x, so the square root of x squared is also going to be x. That's coming outside the radical sign. And here's a y times a y, the square root of y squared is also going to be y. So all that's coming out. So we have this 2 that was on the outside. We have a 5 and an x and a y that are also coming out of the radical sign. We still have this 3 outside of the radical sign. The only thing that didn't have a buddy is the 2. So it stays under the radical sign. So multiply these together. 2 times 5 is 10, times 3 is 30. So we're going to be left with 30 times x times y times radical 2. And finally, this puppy right here. That radical affects both the numerator and the denominator. So we can do this pretty much in one shot. The square root of 4x squared is 2x. The square root of 25y squared is 5y, because 5y times 5y will give us that. There it is. That's what comes out of the radical sign. So it's not too bad once we get the basics and really think about what the radicals mean and what it takes for numbers to come outside of the radical and be simplified.